Welcome back to Clean Tech Talk. Today, we are doing a deep dive into something that honestly sounds like it's straight out of science fiction. We're talking about CO2 cleaning. You might have heard it called dry ice blasting. I've
Yeah,
been looking through the notes and I'm still trying to wrap my head around it. Cleaning heavy industrial gear with, what, frozen gas?
it does sound a little crazy, doesn't it? But it's really just, very smart physics. We're
Yeah.
basically moving on from the old brute force ways of cleaning all that scrubbing, the harsh chemicals, sandblasting,
Right.
and we're moving towards something that's, well, it's sophisticated, it's non-abrasive, and this is the key. It leaves zero secondary waste.
Okay, that's the hook that got me.
Yeah.
How do you blast, say, a delicate circuit board or a huge engine and have the cleaning agent just disappear? I mean, the sources mention supersonic speeds and temperatures of minus 78 degrees.
Yeah, let's break that down because it's not just blowing cold air. It's a really precise three-stage chain reaction.
Okay.
So stage one is what's called kinetic impact. You're using compressed air to fire these tiny, dry ice pellets.
At supersonic speeds, right?
But at supersonic speeds, they hit the surface like microscopic bullets.
It's softer than sand, so they don't damage the surface itself.
Exactly. And that leads to stage two, which is maybe the most important part, thermal shock,
The cold.
the extreme cold. These pellets are negative 78.5 degrees Celsius. So when they hit room temperature grime, think grease or paint or whatever, that contaminant freezes on contact.
It becomes brittle.
Instantly, it contracts, it cracks, and that breaks its bond with the surface underneath.
And that just sets up the grand finale, stage three. This is where the physics gets really cool. Sublimation.
This is the aha moment. The second it hits, the solid dry ice turns directly into a gas. It doesn't melt.
It sublimates.
Right. And in that millisecond, it expands to nearly 800 times its original volume.
Wait, 800 times. So you're talking about a series of tiny, localized explosions happening all over the surface.
That is the perfect way to describe it. These micro-explosions lift the now brittle contaminant right off the surface from underneath. And since the CO2 is now a gas, there's nothing left.
So no sand to sweep up, no toxic wastewater to deal with,
Nothing. The dirt falls to the floor and the cleaner just vanishes into the air.
which explains the huge range of applications. I was reading about electronics cleaning printed circuit boards. Water would cause short circuits.
Of course. But CO2 is non-conductive. It's completely dry. You can clean live electronics with it.
And what about restoration, using it on old buildings?
That's a huge one. It's non-abrasive, so you can clean soot off a historic stone facade without chewing up the original material like sandblasting would. You're preserving history.
The sources also mention the food and pharma industries. It's non-toxic, it's clean.
And it meets good manufacturing practices. You can sanitize equipment without chemicals, which is a massive win for sustainability. And for water conservation, especially in, drought-prone areas.
Okay, but let's ground this a little. The research is clear. This isn't a magic bullet for absolutely everything. It has limitations.
It does. It really relies on that surface impact. So if you have something porous, like wood with grime deep in the grain, it can struggle. Or, say, with really thick rubbery adhesives that can just absorb the impact.
But the technology isn't standing still, is it? We're seeing more automation.
Oh, definitely. Robotic blasting systems, AI for precision targeting. It's expanding into really high-stakes fields. Think nuclear facilities, microchip manufacturing.
I guess it comes down to uptime. The ability to clean a huge machine without having to take it apart for 3 days must change the whole economic calculation.
It's everything. For a plant manager, that downtime is a killer. Cleaning in place is the goal.
So it really is becoming the gold standard for any industry that cares about efficiency and its environmental footprint.
It's clean, it's fast, and it's sophisticated. It's where we need to be headed.
A fascinating look at how physics is cleaning up our dirtiest industries. Before we go, here's a thought. As this tech gets smaller and cheaper, how long until your local car wash is completely waterless? Something to think about. And as a special thank you to our listeners, you can now enjoy 10% off your next purchase at IOLITH. Just use the promo code IOLITH2026 at checkout. That's AIOLITH 2026. Don't miss out.